Good afternoon, boys. So last time we have seen one chapter, rotational motion. We have seen examples, we have seen multiple choice question. Chapter is completed. Let us go further. The next chapter from paper 2. Now next chapter is wave optics. Optics is a branch of physics which deals with light and properties of light. So in this typical branch of science, we only study the concept of light and all things which are related to light. How light travels, how it reflected, how it is refracted, how it behaves when it enters in transparent material. So all these properties we study in this typical branch of physics, namely optics. Wave optics. So from this word itself we can understand wave means a nature of the light. So light travels in the form of waves. So all the concept of light which are related with the concept of wave, this concept is studied in this typical branch of physics, namely wave optics. So wave optics means the study of light by using the concept of wave. Now first point of this chapter, namely the concept of Newton's corpuscular theory. By name itself we can understand that this theory was put forth by scientist Newton. Let us see main points of this theory. First point, with respect to corpuscles. Suppose this is the source of light, just like a candle. So from this, light moves away from the source of light. It goes away from source of light. So according to scientist Newton, this light travels in the form of particles, and these particles are called as corpuscles. So first point of this concept is corpuscles. That means particles which are emitted from source of light. So we can say that light travels in the form of particles called as corpuscles. So we can say that light travels in the form of particles called as corpuscles. Thus, corpuscles are emitted from source of light. So point number 2, second main point of the corpuscular theory is the concept of colors. We know that light consists of different colors. So this different colors has a definite reason. So according to scientist Newton, different colors of light are due to the different sizes of the particles. So size of the particle plays very important role in case of colors. If size is changed, the color of light changes according to scientist Newton. So reason behind different colors is the dimensions, or we can say that size of the particles. Third point, the concept of reflection. When these particles falls on the reflecting surface, then they are repelled by the reflecting surface like this. Suppose this is reflecting surface and light falls, that means particles falls, that means corpuscles falls on this surface just like a mirror. Then this reflecting surface, the mirror has a property to repel. They don't want these particles, so they not allowed to enter in this typical surface. So these particles are rejected, repelled, thrown away from this reflecting surface. In this way, the concept of reflection can be explained properly with the help of scientist Newton. The fourth point, the concept of refraction. We know that when light falls on the refracting surface, that means the surface which separates two medium, air medium and denser medium like glass or water. Then light enters from air medium to the denser medium and changes its path. Similarly, the speed also changes. This phenomenon of bending of light when traveling from one medium to the other medium is called as refraction of light. Let us see what is the concept of scientist Newton about this refraction of light. According to scientist Newton, when light falls on this typical refracting surface, that means particles falls on this refracting surface, that means corpuscles falls on this surface of glass or water, then these particles, light particles, corpuscles are attracted, pulled by the denser medium, that means glass medium, that means water medium, that means denser medium, and therefore it changes its path and speed also increases. So in this way, according to scientist Newton, the refraction can be properly explained. So we can say that when light falls on the refracting surface like glass or water, etc., then these particles are attracted by that surface. In this way, refraction can be explained by scientist Newton by corpuscular theory. Now fifth point, the concept of speed. According to scientist Newton, when light enters into the denser medium, then due to attraction, the speed of the particles increases. So we can say that if we compare the speed of particles before entering into denser medium and after entering into the denser medium, because of this attraction, the speed increases. So we can say that according to scientist Newton, speed of light in air medium is somewhat smaller than speed of light in denser medium due to attraction. So according to scientist Newton, the speed of light in denser medium is bigger than the speed of light in the air medium. Number 6. There are some phenomena like photoelectric effect and Compton effect properly explained by scientist Newton. What is photoelectric effect? When light falls on certain metals, when suitable light falls on the some metallic surface, then automatically from that metallic surface electrons are emitted. This concept, this observation, this phenomenon is called as photoelectric effect. On the other hand, Compton effect means when light falls on the very small particle like electron, then electron as well as light scatters away from each other. So this concept is called as a Compton effect. So this also properly explained by the concept of corpuscular theory. So phenomena like photoelectric effect, reflection, Compton effect, reflection, refraction are properly explained by scientist Newton. These are called as main points, or we can say that merits, plus points, important points, successful points of the Newton's corpuscular theory. Let us see drawbacks of this theory or weak points, or we can say that the points where the scientist Newton failed to explain. Demerits. First point with respect to speed. Just now we have seen that according to scientist Newton, when light enters into denser medium because of attraction, the speed of light in denser medium is bigger than the speed of light in the air medium. So speed of light in denser medium is bigger than speed of light in air medium. But in actual practice, exactly opposite thing is observed. The speed of light in air medium is bigger than the speed of light in denser medium. So why this happens? What is the reason behind this? This concept not properly explained by scientist Newton. So this is called as first drawback, or we can say that weak point, or we can say that demerits of the scientist Newton's corpuscular theory. Second drawback with respect to reduction of mass of source of light. Suppose this is source of light. So from this light emits. So we can say that particles are emitted from source of light. So all these particles travel away from the source of light. And because of these particles going away from the source of light, there is some change in the mass of this typical source of light. So because of this continuous emission of the corpuscles, there should be some reduction in mass of the source of light. but it is observed that in actual practice, practically, the mass remains unchanged. So we consider this is concept not properly explained by scientist Newton. So this is called as second drawback of the corpuscular theory, or we consider Newton's corpuscular theory. Let us see next drawback, the other phenomena. See this diagram. Suppose this is water surface or glass surface, or we consider the refracting surface. When light falls on this refracting surface, like glass surface or water surface, it is observed that there are both things observed. Some part of light is reflected and some part of light is entered in the water or glass. So both things are observed. Reflection and refraction takes place at the same instant. So why this happens? Why these particles are repelled and why these particles are attracted by the water surface, by glass surface, by denser medium? Not properly explained. So we can say that the simultaneous reflection and refraction takes place when light falls on the refracting surface. So this phenomenon of simultaneous reflection and refraction is not properly explained by scientist Newton. So we can say that when light falls on the refracting surface like glass or water, then there is a reflection and a refraction both takes place at the same instant. So this simultaneous reflection and refraction not properly explained by scientist Newton. Similarly, there are some phenomena like interference, double refraction, diffraction not properly explained by scientist Newton's corpuscular theory, and therefore this theory was not accepted, and in place of that a new theory called as wave theory of light, Huygens wave theory of light, was accepted. Let us see what is Huygens wave theory of light. So next time we will see the concept of Huygens wave theory of light. Now we stop here.